Okay, let's say that for what we have in working with electrical networks, okay, we have for this problem, okay, it says to determine the currents I of1, I of2, and I of3 for the electrical network shown in the figure. Okay, now referencing what are referred to as Kirchhoff's laws, okay, and we have for the variables, okay, we have R is in reference to resistance, and the unit measurement is in terms of ohms. And for I, we have current, and the unit of measurement is amperes, or amps for short. And for V, we have voltage, and the unit we have in terms of volts. And for the first of Kirchhoff's laws, okay, we have at a junction, okay, the current going in is equal to the current going out. And also, okay, where voltage is concerned, and we have for a closed path in the electrical network, for each closed path, you're going to have the sum of the products of the resistance and the current in the same path. Okay, it's going to be equal to the voltage in that closed path. Okay, so you got the sum of the products of R and I equal to the voltage in that particular path. And for what we have here, now the resistances we have, the first one is measured at 4 ohms, the second resistance we have at 3 ohms, and the third and last we have measured at 1 ohm. And we're trying to find out what the current measurements I of1, I of2, and I of3 are going to be. And for the voltages, okay, we have V of 1, we'll let this be at 22 V, and for the second we'll have it 23 volts. And looking at applying Kirchhoff's laws, okay, and we can establish, okay, what the paths are going to be. Okay, so first of all, we have at the upper half, notice you have first current, you have going to the left, and the second current we have going to the right. And so you have with your closed path, you have going in a counterclockwise direction. And for the bottom half, okay, you have I of 2 is at the top, I of 3 is at the bottom. And notice that going by the arrows, okay, this is going to be the second pathway. And just for the junctures, okay, we'll just say that the left circle, okay, will be in reference to the first juncture, and the right circle will have that labeled as the second juncture. Okay, so again, we have with Kirchhoff's first law, okay, so the current going in is equal to the current going out. Now again, we have at the first juncture, okay, notice what, notice by the diagram here, so we have with I of 1, okay, so you have going to the left, and if you were to continue would have going down, approaching. Likewise, I of 3 have going to the left and gradually moving up, okay, and approaching 1. But if you notice for the second current, okay, notice by the right arrow, okay, it is moving away. So in terms of what is going in, you have I of 1 and I of 3, and that which is going out, we have I of 2. Notice that we have at the second juncture, okay, we have I of 2 is approaching, as indicated by the right arrow, and then we have going away, we have I of 1 and I of 3. And if you notice, okay, we have these equations are commutative property equivalents of each other. Okay, if I alternate between the left and right hand side, I have the same equation in effect, and if I consolidate the terms into one for the whole system, I can say I have I of 1 minus I of 2 plus I of 3 is equal to 0. Now, for what I have in the case of the second of Kirchhoff's laws, okay, so you have, again, so you have I is equal to 1 to n, and again you have and looking at the second of Kirchhoff's laws. Okay, so you have, again, as I goes from 1 to n, you're looking at the sum of the products equal to the voltage in that particular closed path. Okay, so for what we have in the case of path 1, or the top half of this electrical system, okay, so you have R1 and I of 1. And also we have plus R of 2 and I of 2. And that's equal to V of 1. And we have the resistance measurements already given. Okay, so R1 we have at 4 ohms. And R2 we have at 3 ohms. And again, we have the first voltage, okay, at 22 volts. And for what we have in the case of path 2, okay, so you've got R2, I of 2, R of 3, I of 3 involved. And that's equal to the second voltage. And taking what we have again, so R2, I of 2, R2 again we have at 3. So you have 3 I of 2, R3 we have at 1, so you got plus I of 3. And the second voltage measurement, again, we have at 23. Okay, so just gathering what we have here for our equation. So we have I of 1 minus I of 2 plus I of 3 is equal to 0. And we have 4 I of 1 plus 3 I of 2 is equal to 22 volts. And we have 3 I of 2 plus I of 3 is equal to 23 volts. Okay, and the units are optional. Okay, so we have for the system, okay, so if I establish a matrix, okay, so I have 1 I of 1 minus 1 I of 2 plus 1 I of 3 is equal to 0. And I have 4 I of 1 plus 3 I of 2. There's no I of 3 here. And we have is equal to 22. We have 3 I of 2 plus 1 I of 3 is equal to 23. And so for the system, if I convert what I have to row echelon form at least, okay, what I can do here, I can convert the 4 to a 0. Say I have the second row elements minus 4 times the first row elements. Okay, so just looking at what we have now. Okay, so the first and last rows remain untouched. Okay, so got 4 minus 4 is 0, 3 plus 4 is 7, 0 minus 4 is negative 4, I still have 22. And I want to convert the 7 in the second row to 1. So I can take 1/7 of the second row again. Still have the first and last rows untouched. Okay, so we have in the rewrite, so we have 0, 1, negative 4/7, and 22/7 at this phase. Okay, so I want to convert this 3 to a 0. And what I can do here is take the third row elements and deduct 3 times the second row elements. And we have upon making the adjustments. Okay, so what I'm going to have now, okay, so you got 3 minus 3 is 0, 1, and what's going to be plus 12 sevenths will be 19 sevenths. And I'm going to have 23 minus 22 sevenths. And so for what I'm going to have in this particular case, okay, so we have 19 sevenths from 1 plus 12 sevenths, and 23 or 161 sevenths minus 22 sevenths. This will be 95 sevenths. And for what I have in following through, now I can make this 19 sevenths into a 1. So just multiply the last row by 7 19ths. And for what I'm going to have at this stage, so multiplying by 7 19ths. So we have 0, 0, 7 19ths, and 19 sevenths is 1, and that of 95 sevenths is going to be at 5. Okay, so for what I have now, okay, for the measurements, okay, so right now we have that I of 1 is going to be equal to negative I of 3 plus I of 2, and for I of 2 we have is equal to 22 sevenths plus 4 sevenths of I of 3. And I already have established, okay, that for what we have now, we have I of 3 is equal to 5. Okay, so for what I have now, okay, so looking at back substituting, so I have I of 3 is equal to 5. And I of 2, so I have 22 sevenths plus 4 sevenths of I of 3, which is 5. And guess what? So we have I of 2 is going to be 22 sevenths plus 20 sevenths, and the sum of the numerators will be at 42 divided by 7, so I of 2 is going to be at 6. And for I of 1, so we have the negative of I of 3, so I have negative 5 plus I of 2, which is 6. And we have the I of 1 is equal to 1. So in terms of the measurements, I of 1, okay, so we have 1 ampere. I of 2 is going to be 6 amperes. And again, for the third measurement of currency, okay, that is going to be 5 amperes.